Hi, this is Matthew Park with the YLOC. This is the Lesson 5, 7th grade preview video. Let's get started with number 1. Look at the graph above. Which point shows the number of bottles in a pack? Some things we can notice right away is that our y-axis, this one, would be the number of bottles, while our number of packs would be the x-axis, or that one. Question 1 is asking us that which point shows the number of bottles in a pack? Well, a pack, we can rewrite that as one pack. So if we look at our graph, one pack would be right here. And we go up to our line, and we see that there are 4 bottles in one pack. Therefore, our coordinate, or point, would be 1. We start off with the x-axis, and then our y-axis would be 4. This is the same thing as writing as packs, comma, bottles. In one pack, there are 4 bottles. Number 2 asks us, which point shows that 3 packs contain 12 bottles of soda? Well, this time we're looking at 3 packs, again, right there. So we draw it up towards our graph. And then they're asking us 12 bottles of soda. 12 bottles of soda would be right there. And we connect it to our graph. And our answer would be this point right here. And that would simply just be 3, 12. Pretty simple. Number 3, how many bottles of soda would 5 packs have? Well, here's where it might get a little bit more tricky. But we can see that this is a linear equation, right? So there's a constant increase per pack, right? So if we look, for every 1 pack we go to the right, there are 4 bottles of soda. At 2, there are 8. At 3, there are 12. In other words, each pack of soda we add, we also add 4 bottles. We go right 1, we go up 4. It's like this for every single increment. So we can continue this pattern of 4 up and 1 across for our 5 packs of soda. Right now at 4 packs of soda, we have 16 bottles. So if we were to go up another 4, we would be at 20 bottles. In other words, we would be at the 20 line point up there. And we go across 1, and that would just be at 5. In other words, in 5 packs of soda, we would have 20 bottles. Because of this constant increase in pattern of 4 up, 1 across, we can predict how many bottles of soda would be at 5 in the graph. We can move on. In order to answer the question, we would want to write 20 bottles. You can try this one on your own. Remember that there's always a constant increase since it's a line. Look at your x and y axes and then try your best to solve the problem. We can look at this one next. Describe the error for each and correct the error on 3. A town is fencing a rectangular field that is 200 feet long and 150 feet wide. At $10 per foot, how much will it cost to fence the field? Well, we see here that this is trying to find the perimeter. We can also draw a diagram. So we have a rectangular field that's fenced in, and it's 200 feet long, 200 feet, and 150 feet wide. In other words, this is what our fence looks like. The black is the fence, and inside is the field. We also know that it costs $10 per foot to fence it. So if we were to try to find the perimeter, what they're doing here is incorrect. They're only using one 200 and one 150, when in reality, the perimeter would have to include another 200 and both 150s. Remember, the perimeter is the total length of fencing we have around the field. So instead of doing only one 200 and one 150, we would have to add two 200s and two 150s. So it would look like that. This would give us the total perimeter, and that comes out to be 700 feet. And if we know that it's $10 per foot, we can just multiply it by $10 to get our total cost to fence the field, and that would actually be $7,000, double what they got. You can apply the same reasoning. This one would represent area, and so on. These are simple algebra you've seen in past weeks. Shouldn't be too hard for you. And let's end off with one word problem. You can look at number 1. A rule of thumb states that the ideal weight in ounces of a baseball bat for a high school baseball player is 5 ounces more than 1/3 of the player's height in inches. Part A. Write an expression that describes the ideal weight in ounces of a bat for a high school baseball player who is 8 inches tall. So if we look at the problem again, we see that the ideal weight is 5 ounces more than 1/3 of the player's height. We also define that the player we're trying to find the ideal weight for is 8 inches tall. So taking all this information, if a player is 8 inches tall, the ideal weight would be 5 ounces more than 1/3 of the player's height. So our expression would be this equation: 1/3 of the player's height and 5 more ounces. Part B. One player was 66 inches tall last year. This year, the player is 69 inches tall. How much heavier should the player's new bat be than the bat used last year? Well, we can just plug in two numbers into our earlier expression to find out the answer and just find the difference between the two. First, let's plug in 66. That would turn out to be 27. 1/3 of 66 is just 22. You add that to the 5 and you get 27. And if we plug in the 69, that would turn out to be 28. 1/3 of 69 is 23, and you add it to the 5 to get 28. In other words, if this is last year, and this is this year, the baseball player's bat should be 1 ounce heavier. So our answer would be 1 ounce. That'll be it for today. I hope this was helpful, and have a nice week.